In this video, I will talk about Fourier series chapter 4. Okay, Fourier is a name of mathematician who introduced this series. Fourier series is a series that used in problems that involve vibration and oscillation, especially in physics and engineering. This problem involves the motion that periodic, okay, so we can use Fourier series to solve the problem. Hi class, okay, you can look at my Padlet. One of the real-life examples that we can use Fourier series is tsunami wave. This is the picture of tsunami. So using Fourier series, you can determine the movement of tsunami. So you can look at here the picture of tsunami. This is a motion of tsunami. It looks like sin x and cos x function. So the Fourier series is very useful to determine and to predict the value of tsunami. Okay, before we proceed to mathematical model or the formula of Fourier series and so on, I want you to post one of the examples that you can understand how to use Fourier series in our real life. Okay, I give already example tsunami. Okay, you can try to post. So in this chapter, we have 3 objectives. So at the end of the class, I hope that you will be able to first sketch graph or predict function for Fourier series. Second, you can determine whether the predict function is odd or even. And then the last one, you will be able to obtain or find the Fourier series expansion. In this chapter, you have 4 topics. The first one is periodic function. The second one is even and odd function. The third one is Fourier series for periodic function, and the last one is Fourier series for half-range expansions. Okay, the first topic is periodic function. Okay, meaning that the function is repeated after some value of t. Okay, so for example, I show you the graph 0, 1, 2, 3, 4, and then this is 1. So let's say the graph is like this. This is the first function and then the second function. Okay, the first function and the second function is same from 0 until 2, and then this one is from 2 until 4. So meaning that the function is same, the pattern is same. So we can say that the range is 2. Okay, and then this one is same, right? So this one is we call the periodic function. For this function, the period of capital T is cannot be 0. We look at example 1, show that fx equal to cos 2 pi x is a periodic function and find its periods. So remember that our objective is we want to determine whether this function is periodic function or not. Okay, let us see how to solve this problem. Okay, to show that fx equal to cos 2 pi x is a periodic function is we have to show that fx plus t is equal to fx. Okay, so let us do fx plus t equal to, so cos 2 pi, so x become x plus t now. Okay, and then we expand this using the trigonometry properties. So we get cos 2 pi x cos 2 pi t, and then minus sine 2 pi x sine 2 pi t. Okay, to show that fx plus t is equal to fx, this one cos 2 pi t must be equal to 1. And then this one must be equal to 0. So we can say that fx plus t is equal to fx equal to cos 2 pi x if cos 2 pi t is equal to 1 and then sine 2 pi t is equal to 0. So from here, we can say that this is true when t is equal to 1, 2, 3 and so on. And remember that t cannot be equal to 0. Okay. And then the question asks to find its period, meaning that we need to find t, capital T. So how to find t is the smallest value. Okay, the smallest value we call fundamental period. Okay, this one is smallest value. Okay, so the answer for t is 1. So we can say that t is equal to 1. And then don't forget this one we shown. Okay, this is how to answer example 1. Show that fx is periodic function. Example 2. Determine whether fx equal to sine 5x is a periodic function. If yes, find the period. Okay, so the period is t. And then determine. So, same thing, what you have to do is fx plus t is equal to, you need to make sure fx plus t is equal to fx. So, fx plus t is sine 5. Okay, now x become x plus t. And then using trigonometry properties, you will get, okay, same thing with the previous example. Okay, sine 5x plus 5t. Okay, so you can refer the trigonometry properties. What is sine a plus b? So, sine a plus b is sine a or sine x cos y plus cos x sine y. Okay, sine x plus y is equal to sine x cos y plus cos x sine y. So here sine 5x cos 5t and then plus cos 5x sine 5t. Okay, now we want to determine whether fx is equal to sine 5x is periodic. So, to make sure fx plus t is equal to fx, which is sine 5x, so this one must be equal to 1. And then this one, 0. So, you will get sine 5x. So, same with fx here. So, this one, if cos 5t is equal to 1 and then sine 5t is equal to 0. And then next, from here, we can say that for cos 2 pi is equal to 1 and then sine 2 pi is equal to 0. How to get this? You refer this. Okay, this is cos. Okay, this one is, so this one is 1, 0, negative 1 and 0. Okay, to get 1 here, meaning that this one is 2 pi. And you know that t cannot be 0. Okay, one more is sine. From here, this is 0, 1, 0, negative 1. So, what is the value to get 0? So, we take the same value, which is 2 pi. We know that when cos 5t is equal to cos 2 pi is equal to 1. So, 5t is equal to 2 pi. And then t is equal to 2 pi over 5. Okay, this one is the smallest value. The answer is this.